Triangles chapter 6 theorems. We'll go into all the theorems, important theorems of this chapter. What are similar figures we'll see from this. Similar figures, two figures having the same shape but not necessarily the same size are called as similar figures. Now if you take all circles, the radius might not be the same, but they are all similar figures because they are of the same shape but of different sizes. You can take all straight lines. Wherever you see, all the straight lines are similar, but they are not exactly of the same length. They can be of different length but of the same shape they are. So these type of figures are type of figures which are satisfying these two conditions, that is having the same shape and necessarily not necessarily the same size, are called as similar figures. So now what are congruent figures? We can see all congruent figures are similar, but all similar figures are not congruent. What are exactly congruent figures? We have learned this in 9th class. Congruent figures are those figures which can overlap one over the other. That means if you are putting two circles together, you don't have any other one circle cannot, it's not greater than the other. They overlap each other. They get mixed up in such a way that it will be like a one single circle. So two circles of different radius, when they put one over the other, like two 5 rupee coins, if you take and you're putting one over the other, you cannot, these two are said to be exactly congruent because they can fit one over the other exactly. So similar polygons, what are similar polygons? We'll see. Two polygons are said to be similar to each other if their corresponding angles are equal and the lengths of the corresponding sides are proportional. So now if you take here, means if I take two triangles in this way, take one triangle in this way and one more triangle in this way. If I name this triangle as ABC and this as DEF, you can see from this that if angle A is equal to angle D and if angle B is equal to angle E and angle C is equal to angle F, then these two triangles are said to be similar. So only when these two triangles corresponding angles are equal, then only we can tell. If suppose angle A is equal to angle E, then they are not said to be corresponding angles, because which angle we consider in such a way that that corresponding angle only should be equal to the other triangle. So then we said those two triangles are similar. So lengths of their corresponding sides are proportional. What do we mean by that? If we take this as 2 and this as 4, this as 3 and this as 6, this as 5 and this as 10, the corresponding sides are proportional means 2 by 4 is equal to 3 by 6 is equal to 5 by 10. Now all of these ratios are nothing but equal to 1 by 2, one constant value we are having. That means we can say that the sides are proportional, the corresponding sides are proportional to each other. That is, AB is proportional to D, that is AB by DE is equal to half. AC by DF is also equal to half, BC by EF is also equal to half. Then we can say that the two polygons are similar. So this is the example which you can solve there. Now examples, any two line segments are similar since lengths are proportional. You can see any two straight lines are similar. Any two circles are similar since radii are proportional. So you can have different radii but of the same shape. Size need not be the same. So therefore these two circles are said to be similar. Any two squares are similar since corresponding angles are equal and lengths are proportional. Now here in a square, you take any square, all the angles always will be equal to 90 degrees. You can see here, any square you can see all the angles are 90 degrees. So because the angles are equal, the corresponding angles are equal and also the lengths are proportional. That is, if you take one square as 2, all the sides are equal, so all these lengths will be 2 units. Now if we take one more square of 4 units, you can tell that they are in same proportion. All the lengths of the sides of a square are in equal proportion. Now next, similar figures are congruent if there is a one-to-one correspondence between the figures. So what is this one-to-one correspondence? That is, one angle is equal to the other. What is that? We'll just see. Any two triangles are similar if their corresponding angles are equal. Corresponding angles are what? Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. These are called as corresponding angles. And what are the corresponding sides from these two triangles? AB by PQ is equal to AC by PR is equal to BC by QR. The corresponding sides are proportional. Now we'll go into the very very important theorem which is called as basic proportionality theorem or Thales theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This is the statement of the Thales theorem or basic proportionality theorem. So what does this mean is, if a line is drawn parallel to the third side. Now so a line is nothing but DE. It is drawn parallel to the third side, that is BC is the third side, such that it intersects the other two sides at two distinct points D and E. This line D and E is intersecting the other two sides, that is AB and AC, at two distinct points D and C, such that it divides these two lines in the same ratio, that is AD by DB is equal to AE by EC. This is a statement of the basic proportionality theorem. So now what is given over here? We are given that a triangle ABC, we are having D is parallel to BC. This is given to us. These two, one is a triangle and the other one is D is parallel to BC. So now what do? We have to construct something so that we can prove from basic proportionality. What is that we have to prove? AD by DB is equal to AE by EC. We have to prove that. So in order to do that, we have to do some construction. What is that construction? We'll see. So now draw EM perpendicular to AD and also DN perpendicular to AE. So now join B to E and then join C to D. We are doing this construction part. Now when AD is the base for triangle ADE, ME is the height. Now when you are considering a triangle BDE, the base of this triangle is BD and the height of this triangle is nothing but EM, because we are taking this as an external, it makes an angle of 90 degrees externally. So therefore you consider EM also as the height of the triangle BDE. Taking this part into consideration, we'll prove this now. So now in triangle ADE and BDE, now you can see from here, where is ADE? AD is the topmost part of the triangle divided by BDE. We are taking this yellow part, BDE. So this yellow part in the down, that is between two parallel lines you are having one triangle. One triangle we are taking, which is equal to half into base into height. Now for ADE, the base is AD and the height is EM. So we write it as half into AD into EM. Now for the triangle BDE, BD is the base and EM is the height. So you can write it as half into DB into EM. So EM will get cancelled and half of also will get cancelled. So that is equal to AD by DB. We will take this as the first equation. Now you know that area of a triangle is equal to half into base into corresponding sides. That only I have written in the brackets here. Now what we do is, next we consider two triangles. What are the two triangles we are going to consider? ADE and CBE. ADE and next triangle, CDE. We are taking this other triangle, this other part we are going to take it. So this is the other triangle which we are going to consider. So CDE. For CDE, again you know the base is EC and the height will be DN. It's again one more external perpendicular you can draw to the line EC. Now for ADE, AE can be the base, therefore DN becomes the height. So therefore area of triangle ADE by area of triangle CD is equal to half into AE into DN divided by half into EC into DN, which is equal to AE by EC. So we'll take this as second equation. Since D is parallel to BC, it's given to us. Therefore, triangles we are given that D is parallel to BC. So we are considering two triangles, that is BDE and CDE. If we take the areas of these two triangles, they'll be equal because they're having the same base BC and they lie between the parallels DE and BC. So therefore, this is proved previously in your last year 9th class that this triangles between two parallels and having the same base are equal in area. So taking that into consideration here, area of triangle BDE is equal to area of triangle CDE. So now here when you are considering these two triangles here, area of triangle ADE, and if you are cross multiplying these two, if you are equating these two and cross multiplying, you get area of BDE is equal to area of CDE, which is nothing but it's equal to 1. So therefore you will get it as AD by DB from 1 and 2. AD by DB is equal to AE by EC. So this is which we had to prove. We are dividing when a line is drawn parallel to the third side of a triangle which intersects the other two sides, that is AB and AC, at two distinct points D and E, then it divides this in the same ratio. These two lines in the same ratio, that is AD by DB is equal to AE by EC. We had to prove that, so therefore we proved, which is the statement of the basic proportionality theorem, hence proved. Now what is that? There's a corollary over here. So if in triangle ABC a line D is parallel to BC, intersects AB in D and AC in E, then you're having two corollaries over here. One is AB by AD is equal to AC by AE. AB by AD is equal to AC by AE. That means we are taking this whole part, that is from here to here, A to B, then we are taking this part till here where I put this dot. AB by AD is equal to AC by AE. This we are going to prove in the first part. In the second part of the corollary, we will prove that AB by BD. AB by BD means we are going to consider the second half, this part. In the first one, we consider this top part here. Now we are going to consider this down part. So AB by BD is equal to AC by EC. We will be proving what are these two corollaries. How do we prove this? This is very easy over here. Because in basic proportionality, what information is given, according to that information, exactly sometimes basic proportionality theorem, we can use it however it is necessary using this corollary. We can use directly basic proportionality theorem. Sometimes we have to use the corollaries also to solve the problems. So in order to solve those problems, from basic proportionality theorem, we have AD by DB is equal to AE by EC. You can see here in the last final step we have hence proved over here. So therefore it is AD by DB is equal to AE by EC. DB by AD is equal to EC by AE. Taking reciprocals of both sides, you are just reversing this part. Then you are adding 1 to both of them. So you get DB plus AD by AD, which is equal to EC plus AE by AE. DB plus AD is nothing but equal to AB by AD, which is equal to AC by AE. So this is what is the first corollary. Then the next corollary, again we use basic proportionality theorem. Directly you take the statement AD by DB is equal to AE by EC. In the first corollary, what did we do? We reversed it and then added 1. Now here directly we will be adding 1. So AD by DB plus 1 is equal to AE by EC plus 1, which is adding 1 on both sides. So therefore you are getting AD plus DB by DB is equal to AE plus EC by EC. AB by DB is equal to AC by EC. So we can summarize the above theorem as AD by DB is equal to AE by EC, or AB by AD is equal to AC by AE, AB by DB is equal to AC by AC. So we can take that line segment, either the full line by part of it, or both parts, first part by second part is equal to again the first part and the second part of this second line, two lines. So in that way you can use those three corollaries. Parts or full by part, you can do these corollaries. Okay. Now next, converse of basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So now what is given to us? We are given that if a line divides any two sides of a triangle in the same ratio, that means AD by DB is equal to AE by EC, or AF by FC is given over here. Triangle ABC, given that triangle ABC in which a line L intersects AB in D and AC in F, we are taking, such that AD by DB is equal to AF by FC. Now what we are doing is to prove D is parallel to BC. So when is this D parallel to BC, we'll see. So let us suppose that L is not parallel to BC. So what we are going to do is we are drawing one more line, then through D there must be another line parallel to BC, such that we'll consider that D is parallel to BC. So by using basic proportionality theorem, what do we get? AD by DB is equal to AE by EC. But what is given to us from the question? We are given from here that AD by DB is equal to AF by FC. Okay, so you're getting a wrong assumption, that is AD by DB is equal to AF by FC and also AC by AE. So they are getting here, if you add 1 on both sides, what you are getting here is, but it is given that AD by DB is equal to F by FC. You can reverse it and then add 1 on both sides. You are getting it as AB by AD is equal to AC by AF. So comparing equation 1 and equation 2, you are having there 1 and equation 2 over here. So when you are comparing both of them, you are getting AB by AD is equal to AC by AE and also AC by AF. That means you are getting AC by AE is equal to AC by AF, which means AE is equal to AF. Therefore, this is possible only when E and F coincide with each other. These are not two separate points, they have to be the same point. When they are coinciding with each other, then only this can happen. Then only you can tell that D is parallel to BC. Next, criteria for similarity of triangles. Now we know that similarity of triangles, we are taking corresponding parts and also the corresponding sides are proportional. So now how do we prove this criteria for similarity of triangles? What is given and what we need to prove? We'll just see what are the three criteria we are having. In two triangles, if corresponding angles are equal, so we are taking corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, hence the two triangles are similar. So here we are taking angles are equal, then we are going to prove that the sides are proportional. In the second criteria, we'll take the sides are proportional, then we'll prove that angles are corresponding. Okay, so now here if you're taking this two triangles, here what we are doing is in triangle ABC and triangle DEF, such that you are having corresponding angles are equal. Angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Triangle ABC is similar to DEF, we have to prove that. Now from the construction part, what I am doing is take a point P and Q on DE and DF respectively, such that AB is equal to DP and AC is equal to DQ. Join PQ. So now what we have in triangle ABC and triangle DPQ, the smaller part, this triangle, when we are taking this triangle, what is that which we are going to consider, we'll see. We have seen that since these two triangles are triangle ABC, AB is equal to DP, AC is equal to DQ, BC is equal to, therefore you are having an angle A is equal to angle D, because these corresponding angles are equal. That is also given to us. From construction we got that AB is equal to DP and AC is equal to DQ. So, and also by you having from the given part angle A is equal to angle D, because the corresponding angles are equal. So therefore ABC triangle is congruent to triangle DPQ by SAS congruence criteria. Now what we have to prove that ABC is similar to triangle DEF. So in order to prove that, now you got that angle B is equal to angle DPQ. From here you can see angle B is equal to angle DPQ, this angle, this corner part near P, and angle C is equal to angle DQP. You know that angle A is equal to angle D, that is given to us. So therefore from here you can tell that by simplicity you can angle B is equal to angle DPQ, but angle B is equal to angle E, because this is the corresponding angles are equal of both the triangles. Therefore which implies that DPQ is also equal to angle E, but these are the corresponding angles, therefore PQ is parallel to EF. Since you know that these two angles here, this topmost part over here and this part, these two are said to be corresponding angles. This angle and this angle, and this angle and this angle are said to be corresponding angles. So therefore we can tell that both, from this you can tell, since these are corresponding angles, PQ is parallel to EF. Now in triangle DEF, PQ is parallel to EF. Therefore by using basic proportionality theorem, we have that dP by DE is equal to dQ by DF, which implies that AB by DE is equal to AC by DF, since dP is equal to AB and dQ is equal to AC, which implies that AB by DE is equal to BC by EF, which implies AB by DE is equal to BC by EF is equal to AC by DF. Therefore both the triangles, that is triangle ABC and triangle DEF, are similar. Now we'll go to the next part. In this, what is given is the sides are proportional. We have to prove that the angles are corresponding. The corresponding angles are equal. So if in two triangles, sides of one triangle are proportional to sides of the other triangle, then the corresponding angles are equal, and hence the two triangles are similar. So now what do we do here is, what is given to us, we are having AB by DE is equal to AC by DF is equal to BC by EF. Now we have to prove that triangle ABC is similar to triangle DF. In between we have to prove that the corresponding angles are also equal. So take a point P on DE and Q on DF such that DP is equal to AB and DQ is equal to AC. Join P to Q. Now you have that AB by DE is equal to AC by DF. This is from the given part we are taking. So which implies that DP by DE is equal to DQ by DF. Therefore, by using converse of basic proportionality theorem, we have PQ is parallel to EF. Okay, if one line divides the other two sides of the triangle in the same ratio. Yeah, by using converse of basic proportionality theorem, we have PQ is parallel to EF, which implies that angle DPQ is equal to angle E and angle DQP is equal to angle E. Angle DPQ is equal to angle E and also angle DQP is equal to angle F. That is, this angle is equal to this and this angle is equal to this, because you are having that PQ is parallel to EF because it is dividing this into equal ratio. That is, you have already seen here AB by DE is equal to AC by DF, and also DP by DE is equal to DF by DQ by DF. So by using basic proportionality theorem, you can tell that PQ is parallel to EF. So from that we can get this corresponding angles are equal. So after writing the corresponding angles, can you tell that triangle DPQ is similar to triangle DEF? Because you are having from AA congruence criteria, similarity criteria, you can tell that these two triangles are similar. So now from when they are similar, which implies that DP by DE is equal to PQ by EF. So therefore now you can write this, but AB by DE is equal to BC by EF, which implies that BC by EF is equal to PQ by EF, and which implies that BC is equal to PQ. So now in triangle ABC and the topmost triangle, that is DPQ, we have AB is equal to DP, AC is equal to DQ, and BC is equal to EF. Therefore triangle ABC is congruent to triangle DPQ. By using SSS congruence criteria, you can get that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle R, because DPQ and DEF both are similar. Therefore the corresponding angles are equal. Since the corresponding angles are equal, therefore we can tell that angle B is equal to angle E, angle C is equal to angle F, and angle A is equal to angle D. Now going into the third one, if one angle of a triangle is equal to one angle of the other triangle and the side including these angles are proportional, then the two triangles are similar. So now here, if one angle of a triangle is equal to one angle of the other triangle, here what is given to us, we'll just see here, it's given that one angle, that is if angle A is equal to angle D, and if one of the side is proportional to the other side, that is AB by DE is equal to AC by DF, this is given to us. We have to prove that these two triangles are similar, that is ABC is similar to triangle DEF. Still now we were given corresponding angles are equal, and we were asked to prove whether sides are proportional or not, and then prove that the two triangles are similar. Then second condition, we are given the corresponding sides are proportional, and we had to prove that the angles are similar, and then take that the two triangles are we had to prove that the two triangles are similar. So now here in this, what we are going to do is, we are considering one of these angles are equal and two sides are proportional here. So take a point P on DE and Q on DF such that DP is equal to AB, DP is equal to AB, DQ is equal to AC. So now we are taking it in such a way that then we are going to join PQ. It is given that AB by DE AB by DE is equal to AC by DF. You can see from this condition, this is given to us. So that only I have written here. But DP is equal to AB. But DP is equal to AB because we have just taken the construction part. We have proved that we have taken it as DP is equal to AB and DQ is equal to AC. So now here you can write in the place of AB as DP and in the place of AC as DQ. So DP by DE is equal to DQ by DF. Therefore, by using converse of basic proportionality theorem, we have one side is proportional. Therefore, PQ is parallel to EF. So now in triangle DPQ and DEF, we have DPQ is equal to angle E. You know that since PEQ is parallel to EF, you get that this angle is equal to this angle and this angle is equal to this angle, that is angle DPQ is equal to angle E, angle DQP is equal to angle F. These two are corresponding angles which I have written here. Therefore, triangle DPQ is similar to triangle DEF by using AA similarity condition. You can see because these two angles are equal. If you can tell those two triangles are similar. Now in triangle ABC and triangle DPQ, you have that AB is equal to DP, angle A is equal to angle D and AC is equal to DQ. So by SAS congruent condition, the triangle ABC is congruent to triangle DPQ. That is angle A is equal to angle D, angle B is equal to angle DPQ, angle C is equal to DQP. We have seen this because these are corresponding parts of there, which implies that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Therefore, by AAA similar condition, triangle ABC is similar to triangle DEF. So we can summarize the above criterion as follows. Two triangles are similar if two triangles are equiangular, that is this condition. Similar condition, if anyhow two angles of a triangle are equal, obviously the third angle will be equal. So two triangles are equiangular, it means that is all the three angles are equal, that is corresponding angle of one triangle are equal to the corresponding angles of the other triangle. Then corresponding sides are proportional, that is SSS similar condition, and one pair of corresponding sides are proportional and the included angles are equal. Just now we have seen in the third criteria, by taking these two sides are proportional. We have taken AB and AC are proportional to DE and DF, and angle A is equal to angle D, which is the included angle between these two sides. So these are the two triangles are similar if these are the criterion. Summarize these above criterion as follows. Okay, that is SAS, SSS and AAA. Now next theorem, which is also one of the important theorem, it is areas of similar triangles. The ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. So now the ratio of the areas, that is area of triangle ABC is equal to ratio means you are taking the ratio, that is area of triangle ABC by area of triangle DF is equal to the square of the ratio of the corresponding sides. So what are the corresponding sides over here? AB square by DE square, then BC square by EF square is equal to AC square by DF square. So we have to prove that this areas of these two triangles, that the ratio is proportional to the square of their corresponding sides. So now here we have only one condition given to us, that is we are considering two triangles ABC and DF, and both the triangles are said to be similar. So now we are going to draw AP is perpendicular to BC, DQ is perpendicular to EF. So area of triangle ABC is equal to half into base into height, that is half into BC into AP, and area of triangle DEF is equal to half into EF into DQ. So area of triangle ABC by area of triangle DF is equal to half into base into height, that is BC into AP by half into EF into DQ. So half will get cancelled. We are getting area of triangle ABC by area of triangle DEF is equal to BC by EF into AP by DQ. Now next what we are doing is we are considering the next two triangles. Now in triangle ABP and DEQ, ABP and DEQ, this triangle, in ABP and DEQ, what do we have in this? We have angle ABP is equal to angle DEQ. ABP is equal to DEQ. These two angles are equal. That means therefore here you can see, since a triangle ABC is similar to triangle DF, the corresponding angles are equal. So therefore you get this. Then you have also have angle APB is equal to angle DQE, which is equal to 90 degrees. Therefore by using a similar condition, AB by DE, AB by DE is equal to AP by DQ. This is a second equation which we have now. But AB by DE is also equal to BC by EF. This is also there, since triangle ABC is similar to triangle PQR, that is given for us. So therefore you having AB by DE is also equal to BC by EF. So comparing 2 and 3, we get AB by DQ is equal to BC by EF, which is the fourth equation. So at each and every point, if you want, we can draw the diagram and see, so that you can have a clear vision of it. This is ABC and this is DEF. This is P and this is Q over here. So you can see from by using AA similar condition, you can see that AB by DE is equal to AP by DQ. That is because we proved from AA similar condition. But AB by DE is equal to BC by EF from the given main condition, from the basics here, because these two are similar. So you can have the sides are proportional. So therefore you got this for second and third one. Okay, the first one we got by using the areas. So we got this first one is this part, we got it by using the areas of both the triangles. Then now how do we use the fourth one? How do we get the fourth one? We'll just see. Comparing 2 and 3, we get AP by, because these two left hand sides are equal over here, you can tell the right hand sides are equal. That is AP by DQ is equal to BC by EF. So AP by DQ is equal to BC by EF, you got here. Now from 1 and 4, what is 1? 1 is this. Area of triangle ABC by area of triangle DF is equal to BC by EF into AP by DQ. So here you have tried that first part, that is from 1 and 4 we get that area of triangle ABC by area of triangle DF. In the place of this AP by DQ, we are going to write it from the place of this AP by DQ, we are going to write it as BC by EF here. So BC by EF into BC by EF is equal to BC square by EF square, that is the fifth equation. But we know that BC by EF is equal to AB by DE is equal to AC by DF, because both the triangles are similar. So therefore you can tell that, which implies if you square everything also they are equal, that implies that BC square by EF square is equal to AB square by DE square is equal to AC square by DF square. We take this as sixth equation. Now comparing fifth and sixth, fifth equation, the left hand side you have area of triangle ABC by area of triangle DEF, which is equal to AB square by DE square, which is equal to AC square by DF square, which is equal to BC square by EF square. Hence proved. So areas of the two triangles which are similar is equal to the square of their proportional sides. So that is the about the theorem. This is areas of similar triangles theorem. Next we are having what is called as Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. So now we obviously know that in a right triangle, here we are considering a right triangle which is right angle at B. So if it is right angle at B, now if you want, you can draw the figure in this way also and see, so that you can, to become easy for you. It is B over here, this is A and this is C. So from B to this is D. In this way we are taking this as a right angle triangle, and even this is also right angle over here. So therefore you are having here AC square is equal to, from here you can see AC square is equal to AB square plus this and this square, AB square plus BC square. So now we have to prove that. Draw BD perpendicular to AC. We are doing that construction. In the proof part, what we are doing is we are considering triangle ADB and ABC, the bigger one and the smaller one. So in triangle ADB and ABC, what you can see over here from here, you can see that ADB is equal to ABC, which is equal to 90 degrees, because here this angle is 90 over here. And also angle A is equal to angle A if you are considering this part of the triangle. This part you can see that angle A is also equal to angle A, which is common. So therefore by using double A similar condition, you can tell that triangle ADB is similar to triangle ABC. So therefore you are having AD by DB, AD by AB is equal to AB by AC. So therefore when you are considering those two triangles, here you can draw the figure so that you can see how did you get that. So you are having here B, ABC, and from B we are drawing D, and the other figure, if you are drawing it in this way, this is B over here, A, C, then you are taking this as D, this is 90, this is also 90 over here, this is also 90 over here. So now you are having ADB. So which is ADB part we are taking this part of the triangle is similar to triangle ABC. In what way? Now we have to take the ratio over here. So which ratio do we consider? AD is this part by AB is this part, that is the right angle side part, this part we are taking, is equal to AB by AC. Okay, so this is the part which we are taking here. So which is equal, which implies that if you are cross multiplying, you are getting it as AB square is equal to AD into AC. So in triangle BDC and triangle ABC, we have angle BDC is equal to angle ABC, which is equal to next part of the triangle. If you consider this and this bigger one, you get it again in this way. By using double A similar condition, you are getting triangle BDC is similar to triangle ABC. Since BDC is similar to triangle ABC, again you can take it in that way. You can just consider in this way, like taking AD by AB we have taken, no? Then we have taken it as AB by AC. So here also we are going to take it in the same way. Here we are taking it as DC by BC is equal to BC by AC. So therefore you will be getting it as BC. If you cross multiply, you will get it as BC square is equal to DC into AC. So which is adding 1 and 2, we get AB square plus BC square is equal to AD into AC plus DC into AC. So AB square plus BC square is equal to AC into, if you are taking common here, AC, AD plus DC. Here you can see from the figure, AD plus DC is nothing but AC. So therefore you are getting it as AC into AC, which is equal to AC square. Therefore AB square plus BC square is equal to AC square, hence proved. Next, going into converse of Pythagoras theorem. In converse of Pythagoras theorem, what do we have? We have in a triangle, if square of one side is equal to sum of squares of the other two sides, then the side opposite to the first side is a right angle. So now we are given that the hypotenuse square is equal to sum of square of the other two sides. That is the sum of the longest side square. The square of the longest side is equal to sum of squares of the other two sides. Then we have to prove that the side which is opposite to the angle which is opposite to the longest side is nothing but right angle. So in that way, if you take a triangle ABC, we have to consider triangle ABC. It is here consider a triangle ABC such that AC square is equal to AB square plus BC square. Thus AC square is equal to AB square plus BC square. Construct a triangle PQR such that PQ is equal to AB, PQ is equal to AB, QR is equal to BC, and angle Q is equal to 90 degrees. Okay, this is equal to 90 degrees now. Now in triangle PQR we are doing this construction in such a way that this side AB is equal to PQ, BC is equal to QR, and angle Q is equal to 90 degrees. So now in triangle PQR, we have PR square is equal to PQ square plus QR square. Because it is a right angle triangle, you can use Pythagoras theorem. So therefore PR square is equal to, now you know that PQ square can be written as, because from here you are having PQ is equal to AB, PQ square can be written as AB square, and you are having QR is equal to BC. So therefore QR square can be written as BC square. So therefore PR square is equal to AB square plus BC square you got. That is since PQ is equal to AB and QR is equal to BC. Now you know that PR square is equal to AC square, since AB square plus BC square is equal to AB square plus BC square is equal to AC square, that is given from our condition over there. So therefore in the place of PR square, can we put it as AC? PR is equal to AC here. So therefore getting PR is equal to AC. Now in triangle ABC and PQR, we have AB is equal to PQ, BC is equal to QR, AC is equal to PR by construction, and this is from this one which we have just now proved. So by using triplets congruence condition, triangle ABC is congruent to triangle PQR. Therefore you can see that angle B is equal to angle Q. Because angle Q is equal to 90, therefore angle B is also equal to 90 degrees, that is by CPCT. Hence triangle ABC is a right angled triangle and right angled at B. Now this theorem, midpoint theorem, we usually use, it is done in 9th class. I have just done it here because in some of the problems we use this midpoint theorem. You can see the statement over here and the proof is also given over here. I have done midpoint and the converse of midpoint also, so that it will be useful for your some problems in the further exercise over here. So midpoint theorem, now statement is, the line segment in a triangle joining the midpoints of two sides of the triangle is said to be parallel to its third side and is also half the length of the third side. So here you have to see that D is in triangle ABC, E and D are, let E and D be the midpoints of the sides AC and AB, and we have to prove that D is equal to half of BC and also D is parallel to BC. We have to prove this too. So in order to do this, we do some construction over here. Extend the line D to F and produce it to F such that EF is parallel to EF is equal to DE. That means E is the midpoint of DF. Okay, we have to take that EF is equal to DE we are taking. Therefore E is the midpoint of DF. Then only you are producing this line DE to EF. We are construction we are doing, so we can do it in this manner. It is possible. Whatever construction we are doing in mathematics or in any in this theorems, all these are for our convenience to prove the theorem itself. So now then proof. Consider triangle ADE and triangle CFE. We are considering this triangle and this triangle. So in these two triangles, what do we have? We are given that EC is equal to AE because E is the midpoint. Then also you are given that angle CEF is equal to angle DEA because they are vertically, or AED because they are vertically opposite angles. Next you have also angle DAE is equal to angle ECF because they are alternate angles. You are given that this EF is parallel to you can take the, because you can take that DF is parallel to BC and this is a transversal, therefore DAE and these two are alternate angles. So by ASA congruence criterion, we get that triangle CFE is congruent to triangle DAE or ADE. Therefore you are having angle CFE is equal to angle ADE. CFE is equal to ADE. That means we are proving this angle is equal to this by CPCT. That is only the one angle, and we also can tell that D is equal to EF. This is also from one of the condition. Instead of taking the alternate angles, we can take one more condition. We have taken that E is the midpoint because we are producing E in such a way that D is equal to EF. You can take, instead of this alternate angles condition, when you are taking alternate angles, you have to extend the line D in such a way that to EF such that EF is parallel to BC. If EF is parallel to BC, then we are drawing a this one, what's this called, transversal. Then you can take that this AB is parallel to FC. You have to take AF is also parallel to FC. We are drawing it in such a way that AF is parallel to AB is parallel to FC. I'm sorry. AB is parallel to FC. In the construction part, if we are doing this, then we can write down this alternate angles, and also since E is the midpoint, we have written that E is the midpoint of DE and EF. We have DE is equal to, here we have DE is equal to EF. So we can tell from SCS, we are having this as one alternate vertically opposite angles. We are having this line is equal to this line, that is DE is equal to DF. Here I am writing all the three conditions. Angle DEA is equal to angle CEF. This is one condition which you are having. This is a side which you are having, I'm sorry, angle. Next you are having AE is equal to EC. This is given to us. AE is equal to, because E is the midpoint of AC, and now from construction we have taken that E is the midpoint of DF, therefore DE is equal to EF. So from S similar congruency condition, you can tell that these two triangles are congruent. You can tell that triangle here, these two triangles, from instead of taking it as ASA, I have taken it as SAS. You can even prove it through SAS. I have shown you on top. SAS congruence criterion, you have triangle CEF is congruent to triangle ADA. So therefore you can tell what are all the other parts, corresponding parts of congruent triangles, whatever are left over, all those are equal. Therefore we are having CFE is equal to ADE, angle FC is equal to DAE, and CF is equal to AD. This side is equal to this side. So therefore you are getting that CFE and AD are the alternate interior angles. So assume CF and AB as two lines which are intersected by transversal DF. So similarly FC and DA are alternate interior angles. Assume CF and AB are the two lines which are intersected by the transversal AC. So therefore you can see that if I draw the triangle here, you can understand it more better. We have taken it in this way. So therefore this is named as ABCDEF. Okay, ABCDEF. Okay, here it's telling that if you assume that CF is the transversal for DF and BC, and AB has two lines such that which are intersected by transversal DF. Okay, next similarly here is asking you to assume that CF and AB are two lines which are intersected by the transversal AC. So we can see what are the alternate angles over here. Therefore because they are intersected by this transversal, and we have just now seen the alternate angles are equal for both of them, so therefore you can tell that these two triangles, CF is parallel to AB, CF is parallel to AB, and also CF is parallel to BD. So CF is equal to BD. We have just now seen that because AD is equal to, CF is equal to AD, AD is equal to DB, therefore CF is equal to BD, and we also have that CF is equal to AD. So therefore BDFC, this forms a parallelogram now here. This down part, this whole thing forms a parallelogram. That is this part. This forms a parallelogram. So since this forms a parallelogram, so the properties of parallelogram, we have that BC is parallel to DF, and also BC is equal to DF, and BC is parallel to DA, therefore DE is equal to half of BC, because we have that DE is equal to EF. So hence proved. We had to prove that DE is equal to half of BC and also parallel to the third side. It is also half of the third side and also parallel to the third side. That is BC is the third side and D is the other side. So that is the proof. Now we will go into what is converse of midpoint theorem. In this converse of midpoint theorem, you have a statement: in a triangle drawn triangle line drawn from the midpoint of one side of a triangle parallel to the other side intersects the third side at its midpoint. So now here, when a line is drawn parallel here, the CF of a triangle parallel to the third side intersects the third side. That means when you are intersecting it, it intersects at its midpoint. So now what is given to us over here? ABC is a triangle and D is the midpoint of AB. From D, a line DE is drawn parallel to BC, intersects AC at E. Now we have to show that E is nothing but the midpoint of AC. So now extend DE to F. DE from C, draw a line CF parallel to BA, which intersects DE at F. Okay, which intersects DE. We are going to extend a line from C such that this CF is parallel to AB and also it is touching the point E on AC. So now since BD is parallel to CF, we are having here BD is parallel to CF. These two lines are said to be parallel. It's given to us. Therefore, from this what can we conclude? And DF is parallel to BC and DF is parallel to BC. These two are parallel here. So since these two are parallel, you have BDFC is a parallelogram, and since BDFC is a parallelogram, the opposite sides of a parallelogram are equal. Therefore, you can take that. If you consider the triangle, if you can draw it here once again, you are getting it as in this way. A, B, C, this is D, right straight, D, E, F. So now here opposite sides of a parallelogram are equal, means you are having here DF is equal to, AD is equal to BD. It is given to us that these two are equal, and also AD is equal to CF. This part also it's equal. So from D is the midpoint of, since D is the midpoint of AB. So therefore in triangle AED and triangle CEF, you have AED and CEF as vertically opposite angles. Therefore you can have angle AD is equal to EFC. That is, these two angles are equal. Therefore vertically opposite angles, and this as AB is parallel to CF. Now AD is equal to CF from equation 1 we having here. Therefore triangle AED and CF are congruent by AS congruency rule. Therefore AE is equal to ES. AE is equal to EC by CPCT. Therefore we can tell that E is the midpoint of AC. We had to prove that. Now what are the two conditions we took here? We took that angle ADE, this is because these two lines are parallel, that is this line is parallel to this, and transversal. AD is parallel to CF and AC is the transversal, DF is the transversal. We took angle AD is equal to angle EFC. Those are alternate angles. Then AD is equal to CF is from equation 1 we got, and also we having vertically opposite angles. Therefore from AS congruency criteria you can tell that AE is equal to EC. This is by CPCT. The congruent corresponding parts of congruent triangles are equal. Therefore E is said to be the midpoint of AC. So these are all the important theorems for which we'll be using for chapter triangles. So next, in the next video, upcoming video, you'll have only solutions for 6.1, then 6.1 and 6.2. Then you'll have one more video coming up for 6.3. For each exercise of triangles, you'll be having one.